Well, hello. How are ya? Alrighty. Today we got section 757. It's talking about inequalities in two triangles now. Last time we talked about inequalities in triangles with a few theorems actually, and now we're going to talk about with two triangles when we're comparing two triangles. We've got a couple of theorems here, new theorems today as well. So our goal for today is to apply inequalities in two triangles. Very simply put. If you notice in the background, there's a couple of basketball players. That's actually a high school basketball game. If you can figure out who the guy to the right is, and let me know next time you see me, I'll give you a piece of candy. He's someone that I played against in high school, and he's actually in the NBA right now, making the big bucks. So we're gonna go on with this section, which is about inequalities. So let's start off with this essentially understanding this thing that we need to kind of get in our heads. In triangles that have two pairs of congruent sides, so you have two different triangles that two pairs of congruent sides, there is a relationship between the included angle and the third pair of sides. So that's going to come in the Hinge theorem here. It's also called the side angle side inequality theorem. And I'll tell you why. Here's what it says. It says if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent. So we have the two sides congruent. We have them labeled here. This one's congruent to this one, and then this one to this one. And we know that the angles are not the same, as you can see from the picture. Then the longer third side is opposite the larger included angle. Meaning, if this is the larger angle here, then it's opposite the larger side. All right. So we know that if measure of angle A is greater than measure of angle X, then BC, the length of BC is greater than the length of YZ. Let's put that into practice here. We got a couple examples. The first one, number one, what is the inequality relationship between the length of LP and the length of XA in the figure to the right? So we have two sides congruent. Here's another one. And we know that this is a right angle M, and angle Y is not quite. It's just a hair over it. It's 93 degrees. So the relationship there is the larger angle has a larger opposite side. So that means that XA is actually greater than LP in this case, based on what we know. Okay, because that would be 90 degrees right there. And the other one is 93 degrees. All right, so let's take a look at this one. You can certainly try this one on your own first if you'd like. But it says, at which time is the distance between the tip of a clock's hour hand and the tip of its minute hand greater? 5 o'clock or 5:15? So you're going to have to know how to work a clock. All right. So I'm going to quick draw a clock here. Let's actually make this a perfect circle. So I'm going to make my shape here. And let's see. There's a clock. All right. I don't have the numbers on there. But I'm going to have you. Something happened to my. There we go. Um. All right. So 5 o'clock. 5 o'clock. We have it. Um. That's the 12 up there. We have the 6 here. We have the 3 here. We have this 9 here. So 5 is going to be right about here. If I fill this in. 1, 2, 7, 8, 10, 11. So our 5 o'clock is going to go here and here. And I'm actually going to use the same one. I changed my mind. I don't need that second one. 5:15 is going to be probably just past the 5 and then over at the 3, which makes 15. So you can tell there, it says at which time is the distance between the tip of the clock's hour hand and the tip of the minute hand greater? Well, you can tell it's going to be the 5 o'clock. Just because of this picture, you can actually just take a look at it. This angle is going to be a lot bigger, so the opposite side will be a lot bigger. Whereas this angle is smaller, so this opposite side is smaller. All right? So that's using that Hinge theorem or that side angle side inequality theorem. We can also do the inverse of this, or sorry, the converse. The converse of this theorem says if two sides of one triangle are congruent to two sides of another triangle, and the third side are not congruent, then the larger included angle is opposite the larger third side. So now we know that we have two congruent sides, so that's where the side angle side. But now it's actually side 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 because we know which third side is larger. In this case, we're saying BC is larger than YZ, and then we know that the measure of angle A would have to be larger than the measure of angle X based on this theorem. So let's use it. Here we got a couple examples. Number 3, it says find the range of possible values for each variable. Looking at the picture, we have congruent side in each, second congruent side on each. And we know the lengths of the third side. So, in other words, the measure of angle D is going to be greater than the measure of angle G because they're opposite sides, because of the lengths of their opposite sides. So we know that 58 has to be greater than 3x minus 2. And then we can solve for x. Don't have a lot of room here, so I'm going to move this, shrink it a little bit. What we can do there is add 2 to both sides. We have 60 is greater than 3x. Whoops. And we divide both sides by 3. We get 20 is greater than x, or x is less than 20. So that's the range of possible values. Anything less than 20 would make sense, would be okay for this x value based on what we know about the sides and the side inequality theorem, or the converse of this Hinge theorem. Now for number 4, we have two triangles, but they're sandwiched together here. We do have a side and a side congruent. We also have this is the reflexive property, so that included side, the one that's touching, it would be the same as well. And we have the third side's length. So in this case, we know that the one that's opposite of 14, that angle has to be greater. So 86 has to be greater than the angle opposite 8. So it's opposite 2x minus 4. And we can do the same thing here. Solve for x and get our range. Divided by 2, divided by 2. You end up getting x, well, if you flip it around, x is less than 45. Alright? One third example, we're going to do a little word problem here. Somewhat. So an equilateral triangle has side lengths of 5. I'm going to assume these are all 5. And an isosceles triangle has side lengths of 5, 5, and 4. So 5, 5, I know it's not just scale, and 4. Right? An inequality for x, the measure of the vertex angle of the isosceles triangle. So we want to write an inequality based on this. So, what we know about the equilateral triangle, we know all the sides are congruent, but we also know that all the angles would be congruent then as well. So remember, for an equilateral triangle, if they're all congruent and they all add up to 180, then they're each 60 degrees. So the corresponding side that we're talking about here would be 60 degrees. And since the opposite side is larger than the opposite side in the isosceles triangle, we'll say this is the vertex angle x. X has to be less than that. X would have to be less than that 60 degrees. Alright, there's the converse of the Hinge theorem for you. Now, what I'd like you to do is try, so it's use the inequality to describe the restriction on the value of x as determined by one of those two theorems. I have 4 examples for you. I'd like you to try them all. And I'm going to pause it, and I'll come back and show you the answers in just a sec. So why don't you pause it now and work through these 4 examples. Alright, so to check how you did, if you want to take a look at my work, if you want to also then take a look at my answers, you can pause it as you need to. But for 1, you should get x is greater than 9. For 2, you should get x, once you solve it, you should get x is greater than 1. For 3, you get x is less than 17.5 or 17.5. And then for number 4, we get x is greater than 28. Right, so applying those two theorems, that's how we would get those inequalities. Alright, the only thing that's left for this section, I'd like you to try is the error analysis. It says, what is the range of possible values for x? And the work is worked out for you, and you need to find the error. Find the error here. And then I also want you to think about this closing question. It says if each of two triangles has two congruent sides, how how are their included angles related? So thinking back to what we've learned today, and that goes straight back to what we've been talking about with this goal of applying inequalities in two triangles. All right, that's all I have for section 5-7. Hope you have a great rest of your day.